Let's talk a bit about function transformations. So, as far as the transformations go, we have up, down, left, right, and those are all translations. We have reflections. Those. And then we have stretch, compress. But we also have X changes and Y changes. So if we were dealing with a function y equals square root of x, if I wanted to go, so the x changes left and right happen inside the function next to the x. And the x variable lies, meaning this one, it says plus 2, but this is left 2. This one says minus 4. You'd think it's left 4. No, this one's right 4. So it's opposite of what you think. Now we can also do a reflection. And this would be if you change the x, let's see, a reflection of the x change. If you think about something changing the x, it's actually a y reflection where the x changes. And the x itself will be negative. And then we have the stretch and compress. But notice all of this stuff happens inside the function next to the x. It's very easy to spot that these are x changes. Change the x to negative x, that's a y reflection. Change the x to 2x, change the x to x minus 3, change the x to an x plus 2, etc. These are all x changes, and they all lie. So this times 2, you would think this would be a stretch. This is a compress. It's opposite of what you think. And a divide by, you would think that that would make it smaller. No, this stretches. So that's what I mean by the x changes, the x lies. It's not what you think. It's the exact opposite. Now, if the y changes, up, down, these all happen outside the function, like plus 3 or minus 4. And this is what you tells the truth. Lies, truth. This is what you think would happen. This one's actually up 3, and this one's down 4. Reflections. The negative isn't inside, it's outside the function. And that reflection, that's when you change the y, that's an x reflection. Compress and stretch. Again, it tells the truth. You times 3, that's a stretch. Specifically, it's a vertical stretch because these are all the y changes. Whereas over here, this is a horizontal compression because that's an x change. Divide by 4, compress. Hopefully this helps you see when you see a number inside a change to the regular function, you can recognize if it's an x change, left, right, a y reflection, or horizontal compression stretch, or if it's a y change outside the function. And the x lies, it's the opposite of what you think, and the y tells the truth. When you see a plus 3 outside the function, it is up 3. All right, hopefully this answers some questions about how to better understand and remember these transformations of functions.